everyone, this is Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem. Solve x squared plus 2xy minus y squared into dx plus y squared plus 2xy minus x squared into dy equals to 0. Solution. Given differential equation. X squared plus 2xy minus y squared into dx plus y squared plus 2xy minus x squared into dy equals to 0. Right? Now, let's take this term involving dx to RHS. Then we'll get y squared plus 2xy minus x squared into dy equals to minus of x squared plus 2xy minus y squared into dx. Now, let's bring all these three terms to, let's bring differential dx to LHS and take this to RHS. Then we'll get dy by dx equals to minus x squared minus 2xy minus into minus plus y squared by y squared plus 2xy minus x squared, which is in dy by dx equals to some function of xy form, right? So now let f of xy equals to this function minus x squared minus 2xy plus y squared by y squared plus 2xy minus x squared. If function of kx, ky equals to function of xy, then we'll call this function as homogeneous function, and then the differential equation involving homogeneous function will be called as homogeneous differential equation. Now let's find f of kx, ky. Simply replace x by kx and y by ky in f of xy. Then we'll get minus kx whole square minus 2 into kx into ky plus ky whole square by ky whole square plus 2 into kx into ky minus kx whole square, which is equals to minus kx whole square can be written as k square x square minus 2k into k square xy, 2k square xy plus ky whole square can be written as k square y square by k square y square plus 2 into k square, this is k, okay, k into k square into xy minus kx whole square can be written as k square into x square, right? Now, we can take k common from all the three terms of numerator and the denominator as well, and this becomes k square times minus x square minus 2xy plus y square by k square times y square plus 2xy minus x square. So here k square gets cancelled from the numerator and the denominator. Then we'll get minus x square minus 2xy plus y square by y square plus 2xy minus x square, which is a function of xy, right? Minus x square minus 2xy plus y square by y square plus 2xy minus x square. So therefore, function of kx, ky equals to function of xy. From this we can say that this function is a homogeneous function, and the differential equation involving homogeneous function is called homogeneous differential equation. Right? So we are given a homogeneous differential equation. Also we can say the given equation is homogeneous by simply looking at the powers of the equation. So in the first term you are having 2, right? Power of first term is 2, say. And here you are having x to the power 1 and y to the power 1. Add these two powers, you'll get 1 plus 1, 2. And here you're having 2. Here also 2. 1, 1, 1 plus 1, 2. Here also 2. 2, 2, 2, 2, 2. So here the powers are same. So from this we can say that the given differential equation is homogeneous. Okay, powers of each term is same. Fine. Now we need to find the general solution to the given equation. So we'll proceed homogeneous method. Let y equals to bx. Now differentiate on both sides with respect to x. Then dy by dx equals to, here we'll use uv whole dash formula, which is equals to u dash v plus v dash u. Then dv by dx into x plus dx by dx into v. Then we'll get dy by dx equals to x into dv by dx plus v into derivative of x with respect to x is 1. Then dy by dx equals to v into 1 is v plus x into dv by dx. Right? Let y equals to vx and dy by dx equals to v plus x into dv by dx. This is y, okay? Fine. Now, replace dy by dx by v plus x into dv by dx. That is, we'll replace LHS by v plus x into dv by dx equals to, now replace y by vx. Then we'll get minus x square minus 2x into y, for y equals to vx plus y square, for y equals to vx, we'll get vx square in the place of y square by vx square plus 2x into vx minus x square. This equals to minus x square minus 2 into v into x into x square plus v square x square by v square x square plus 2 into v into x square minus x square. Now take x square common from all the three terms of numerator and all the three terms of denominator. Then we'll get x square times minus 1 minus 2v plus v square by x square times v square plus 2v minus 1. Right? Now we can cancel x square from the numerator and the denominator. Then we'll get minus 1 minus 2v plus v square by v square plus 2v minus 1. So now we have v plus x into dv by dx equals to minus v minus 2v plus 2v square by v square plus 2v minus 1. Now take this v2 RHS. Then x into dv by dx equals to minus 1 minus 2v plus v square by v square plus 2v minus 1 minus v. This becomes minus 1 minus 2v plus v square minus v into v square plus 2v minus 1 by LCM. V square plus 2v minus 1 is equals to minus 1 minus 2v plus v square minus v into v square v cube minus into plus minus v into 2v square minus into minus plus v into 1v by v square plus 2v minus 1 is equals to minus 1 minus 2v plus v is minus v, okay, v square minus 2v square or minus 2v square plus v square is minus v square minus v cube by denominator will be as it is. Now we have x into dv by dx equals to minus 1 minus v square minus v cube by v square plus 2v minus 1, right? Now let's take minus common from the numerator. Then we'll get minus of 1 plus v square plus v cube by denominator. Also you can write all the four terms as v cube plus v square plus v plus 1 by v square plus 2v minus 1, right? So we have v cube plus v square plus v plus 1 in the numerator, right, under the brackets. So now we can take v square common from the first two terms, and we'll get v square times v plus 1, right? And the last two terms remains the same. So if you notice, we are having v plus 1 in both the terms. So let's take v plus v common from these two terms, and we'll get v plus 1 times v square plus 1, or right, let it be. So now let's replace the numerator under brackets by v minus 1 into v square plus 1 by denominator remains the same, v square plus 2v minus 1. Right. See, you're having differential dv in the numerator of LHS, right? So now we'll take all the functions of v and differential dv to LHS and functions of x and differential dx on the other side. Then we'll get v square plus 2v minus 1 by terms under square brackets v plus 1 into v square plus 1 into dv equals to minus, here you'll have minus 1, right? So you'll get minus 1 by x into dx. So here the variables are separable. Now we can perform integration. Integral v square plus 2v minus 1 by v plus 1 into v square plus 1 into dv equals to minus integral 1 by x dx. I'm writing the same step here. V square plus 2v minus 1 by v plus 1 into v square plus 1 into dv equals to minus integral 1 by x into dx. See, we can replace the terms under square brackets by this here itself, or we can replace it later, like by writing all the functions of v and dv on one side and functions of x into dx on the other side. Now also you can replace v square plus 1 into v plus 1, right? Here we can replace the denominator by this, okay? But in the previous steps we have replaced in the RHS itself, okay? You can prefer this otherwise. Better if you replace later like this. Because few people may not estimate the next step. So it is good to replace like this, okay? Like I showed now. Fine. Now, consider the integrand of LHS v square plus 2v minus 1 by v plus 1 into v square plus 1. Okay. See the given fraction, or this fraction is a proper fraction. The degree of numerator is 2 and the degree of the denominator is 3. So degree of numerator is less than degree of denominator. So from this we can say that the fraction is a proper fraction. Well, now we'll resolve this to partial fractions. Okay, a by linear term plus the second term you're having quadratic, so we'll get a linear term in the numerator by v square plus 1, then v square plus 2v minus 1 by v plus 1 into v square plus 1 equals to, take the LCM of v plus 1 into v square plus 1, v plus 1, 1's are v plus 1, v square plus 1, 1's are v square plus 1. So v plus 1 into v square plus 1 is the LCM of these two. The numerator will get a times v square plus 1 plus bx plus c times, here in the denominator of second term you're having v square plus 1, so cover v square plus 1, remaining will be v plus 1, so we'll multiply v plus 1 to this. Now we can cancel the denominator, then v square plus 2v minus 1 equals to a times v square plus 1. Sorry, this is v, not x, okay? Fine. Plus bv plus c into v plus 1. If v plus 1 equals to 0, then v equals to minus 1. Now let's put v equals to minus 1 in this equation. Then we'll get minus 1 whole square plus 2 into minus 1 equals to a times minus 1 whole square plus 1 plus b times minus 1 plus c into minus 1 plus 1. Since minus 1 plus 1 is 0, so the second term becomes 0, right? Then this becomes minus 1 whole square is 1, minus plus into minus is minus, 2 into 1 2, 2 into 1 2, minus 1 equals to a times minus 1 whole square is 1 plus 1. Then here plus 1 minus 1 gets cancelled and we'll get minus 2 equals to 1 plus 1 2a, or 2a equals to this a. 2a equals to minus 2. From this we'll get a equals to minus 2 by 2, which is minus 1, right? So we have a equals to minus 1. I'll just simplify this equation to one more step. ab square plus a plus bv into v square plus bv into 1 bv plus c into v cv plus c into 1 c, right? Now let's compare the quotients of v square. We'll get v equals to a, sorry, not v, 1. Quotient of v square is 1 in LHS, right? So 1 equals to a plus b. Since we have a equals to minus 1, so let's replace a by minus 1. Now bring this minus 1 to LHS, you'll get 1 plus 1 equals to b. Then 2 equals to b, that is b equals to 2. Now we need to find the value of c, right? So we have c in the quotient of c as the quotient of v and constant. So now let's compare constants. Okay? Minus 1 equals to constant a c plus c. Then minus 1 equals to, for a equals to minus 1 plus c. Now bring this minus 1 to LHS, you'll get minus 1 plus 1 equals to c. Minus 1 plus 1 is 0. So c equals to 0. Now let's substitute the unknown values. We'll get minus 1 by v plus 1 plus b into, sorry, for b equals to 2, we'll get 2v plus 0 by v square plus 1. This is equals to minus 1 by v plus 1 plus 2v by v square plus 1, right? We have resolved the given, not given fraction, this integrand to partial fractions. Fine. So now we can replace this by these two terms. Then integral of minus 1 by v plus 1 plus 2v by v square plus 1 into dv equals to minus integral 1 by x into dx. Then minus integral 1 by v plus 1 into dv plus integral 2v by v square plus 1 into dv equals to minus integral 1 by x dx. Since we know that integral 1 by ax plus b into dx equals to 1 by a log ax plus b, and integral f dash of x by f of x into dx equals to log mod f of x, and also integral 1 by x dx equals to log mod x, right? Now minus for a equals to 1 and for a equals to 1 and x equals to v and b equals to 1, simply compare the integrand, then we'll get to know what is x, what is a, and what is b, right? For a equals to 1, x equals to v, and b equals to 1, you'll get 1 by 1 log 1 into v plus 1, simply log denominator, or here you can use this formula. Okay, you can compare these two integrands simply. For f of v equals to v plus 1, f dash of v will be derivative of v with respect to v is 1 plus derivative of a constant with respect to v is 0. Then for f dash of v equals to 1 and f of v equals to v plus 1, will get integral f dash of v by f of v into dv equals to log mod f of v, that is log mod, that is integral simply 1 by v plus 1 into dv equals to log mod f of v, for f of v equals to v plus 1. Okay, you can use any of these two formulas to evaluate the first integral. Plus, now let f of b equals to term in the denominator, then f dash of v will be derivative of v square with respect to v is 2v plus derivative of a constant with respect to v is 0, which is 2v, then integral f dash of v by f of v into dv, simply we are applying this formula for x equals to v. Okay, log mod f of v, right? Then integral for f dash of v, that is 2v by f of v square plus 1 into dv equals to log mod f of v, for f of v equals to v square plus 1, right? So integral 2v by v square plus 1 into dv is log mod v square plus 1. Equals to minus integral 1 by x dx is log mod x plus you'll get an integral constant, right? Since all the three terms are in log, so we'll write integral constant as log c in terms of log. So the above equation becomes minus log v plus 1 plus log v square plus 1 equals to minus log x plus log c. We'll rewrite it as positive term, that is term involving positive sign first. Now term involving negative sign equals to term involving positive sign log c, and term involving negative sign minus log x. Since we know that log a minus log b equals to log a by b, then this becomes log a minus log b equals to log a by b, for a equals to b square plus 1 by, for b equals to b plus 1 equals to, similarly here also log a minus log b will be log a by b, right? We know that if log a equals to log b, then a equals to b, and this becomes b square plus 1 by b plus 1 equals to c by x. Right. Since y equals to bx, you can write it as bx equals to y. From this we'll get v equals to y by x. Now let's replace v by y by x, then y by x whole square plus 1 by y by x plus 1 equals to c by x. This becomes y square by x square plus 1 by y by x plus 1 equals to c by x. Now take the LCM from the numerator and the denominator as well. Then in the numerator x square will be the LCM. Y square plus 1 into x square by LCM x square by, here x is LCM, you'll get y plus x by x equals to c by x, right? Now we can just write this as y square plus x square by x square into x by y plus x equals to c by x. Then you can write this as y square plus x square into x by x square into y plus x equals to c by x. So 1x gets cancelled from LHS. Then we'll get y square plus x square by 1x remains in the denominator. You'll get x times y plus x equals to c by x. So this x and 1x from RHS gets cancelled. Then y square plus x square by y plus x equals to c. Right. Now we can take this term to RHS. Then we'll get y square plus x square equals to c times y plus x. Which is the required solution. So this completes the problem. So we have seen a problem from homogeneous differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.